Hello, welcome to our channel. In this video we are going to understand AWS Kinesis data stream consumer using Java. So don't miss any steps and be with us at the end of the video. Our Java development team is sharing this video with global developers who want to learn how to implement Kinesis technology and cloud computing to achieve modern streaming of data. You may proceed and view this video further to learn the basics and specialized code for Kinesis implementation. Let's understand. What is the cloud? The term cloud does not refer to the clouds in the sky. In the words of Wikipedia, it means cloud computing involves deploying groups of remote servers and software networks that allow centralized data storage and online access to computer services or resources. I personally have a different version to it. It is a term specifically used in the tech industry, which means that anything and everything can reside centrally and be shared without having to worry about the local storage or even local computing powers. Consider the case wherein a product that is developed has to be deployed for people to access it. The normal algorithm would be to buy huge servers and database space, deploy the application and pay for the usage of the services. Most of the time, the servers are being unused, the processing power wasted, and the database disk not fully utilizing its true potential. This results in the monetary loss of the company developing the products as well as a waste of technological resources. To address such situations and others, all of them quite grave, the concept of cloud computing came into existence, which aimed at sharing the resources centrally and thereby achieving a win-win situation. There are three ways which define the sharing of resources. First, infrastructure as a service means IaaS. IaaS is a type of cloud computing in which a third-party provider hosts virtualized computing resources over the internet. Second, platform as a service means PaaS. PaaS is a cloud model in which providers deliver apps over the internet and host users' hardware and software on their infrastructure. Third, software as a service means SaaS. SaaS is a software distribution model in which applications are hosted by a vendor or service provider and made available to customers over a network, typically the internet. Next, let's understand. What is the Amazon Web Services? Amazon Web Services, AWS, is another name for cloud in whatever manner it is defined. AWS comes with a bunch of services, all of them catering to the cloud model that allows any application to use the powerful advantages that the cloud model suggests. Starting from sharing of the processing power, to the database, to the security system, to the sharing of computer hardware, it is the one-stop shop for any cloud requiring application. The screenshot lists all the components of AWS as you can see here. Next, understand Kinesis, the road to modern streaming of data. To use AWS Kinesis, or as a matter of fact, any AWS services, one must download the AWS SDK to use its features. Specifically for Kinesis, one must also download an additional library that helps in the development of a consumer, one that received the data in a much easier fashion. In the case of Maven usage, the following snippets of code are used to download the SDK. If Maven is not present, one can manually download the AWS Java SDK from the internet. Check out this in below snapshots as mentioned here. The versions can be changed to suit the needs. Next, understand Amazon Kinesis Architecture. Before proceeding further, it would be nice to understand some technical jargon associated with Kinesis. Here, you can see the image of Amazon Kinesis Architecture. First is stream. A stream represents an ordered sequence of data records. The data records in a stream are distributed into shards. Second is shards. Internally, each stream stores its data in shards. The number of shards that each stream will have is a volatile variable. It depends on the fact at what rate the producer is producing data and at what rate will the consumer consume data. Each shard can read at 2 megabytes per second or maximum 5 transactions per second and write at 1 megabyte per second or a maximum of 1000 writes per second. The image shows the internal structure of a third is producer, one who sends, produces the data to Kinesis. For example, a web server sending analytics data to a stream is a producer. Fourth is consumer, one who receives means consumes data from Kinesis. Here, first one is a normal consumer. A normal consumer is built using the basic Amazon SDK. It requires a lot of overhead to be handled manually, like when a shard is split means resulting into shards from one and hence double the stream capacity, or merged means resulting in one shard from two and hence half the stream capacity. The code has to handle these transitions and fetch the data accordingly. Likewise, in case of stopping the code and reading data again later, the consumer has to keep a track of how much data has been read previously and hence read from that point. Second is KCL consumer. KCL is a library offered by Amazon that handles all the heavy chores such as the one mentioned above and directly offers a channel that reads the data from the stream and presents it to the user for further manipulation. The second entry of the library above is specifically for KCL and is not a part of AWS SDK. Now next to the fifth point. It is partition key. A partition key is used to group data by shard within a stream. Partition keys are Unicode strings with a maximum length limit of 250. Sixth is sequence number. Each data record has a unique sequence number. It is the responsibility of the producer to assign each data record a unique sequence number whilst it is adding data to the stream. Seventh is application name. Each Kinesis application is identified by a unique application name. The application must have a unique name across the Amazon account and region used by the application. Now next, understand Kinesis API. The following are the most important Kinesis API calls that are used very frequently and are the ones that we have been using in our projects. In this, first one is create stream. This is the API call that is used to create a stream in an AWS account in a particular region. You can see the image we mentioned here. One has to specify the region when creating the stream. AWS, with all of its services, is distributed in many different regions around the globe. The region is specified as follows mentioned image. The endpoint can be one of the many values as defined below mentioned image. Second one is describe stream. This is the API call used to check on the stream. It is used to describe the stream in terms of whether it is active or not, how many shards are there, when was it last modified, etc. As you can see in mentioned image. Kinesis client is a variable that has been initialized as an establishment to AWS Kinesis. Next, third one is put records. This API call is used by the producer while adding data to the stream in Kinesis. As you can see in mentioned image, one has to set the partition key while adding data to the producer. It is necessary for the producer to add the data wrapped in a byte buffer because that is how Kinesis accepts the data. Fourth one is using shard iterator to retrieve records. This is the conventional approach to fetching data from the stream. It is not recommended to use this approach anymore since there is a more efficient approach that means KCL. Next, sixth one is merge shard. This operation is used when the producer is producing less data than the capacity of the total number of shards. In such a case, The situation is such that the operation will not be affected even when there is one shard lesser in the stream. This is primarily done to reduce the costs because the cost of a stream is associated with the number of shards in it. Seventh one is split shard. This operation is used when the producer is producing more data than the capacity of the total number of shards. In such a case, the situation is such that if not done anything, Kinesis will not be able to ingest all the data that is being produced by the producer because the capacity of the stream is less than the capacity of the producer producing data. A split shard will result in an increase in cost because the cost of a stream is associated with the number of shards in it. Eighth one is KCL. This is the most efficient approach to read data from the Kinesis stream since the library handles all the heavy tasks in the backend and leaves the user with the data. As you can see in mentioned image, the app name is the table name that is created in DynamoDB for checkpointing purposes. The initial position is a variable that tells KCL from where to start reading the data in the stream. It can have one of the two values. First one is latest, start reading the latest data in the stream. Second one is trim_horizon, start reading from the beginning of the stream. The key component in KCL is the record processor. One has to implement the record processor.java, which extends record processor factory class. The key methods to be implemented are: first one is initialize. This method is used for any initialization required. Second one is process records. This is the key method that is responsible for delivering the data. Third one is checkpoint. This method is used by KCL for checkpointing how much data is read previously. The checkpointing is done in AWS DynamoDB, again an AWS service. Ninth one is delete stream. This API call is used to delete a stream from a particular region from AWS Kinesis. As you can see mentioned image. At the end of the video, I like to say our team is glad to share this video with global developers and let them learn about the implementation of Kinesis and cloud for the modern streaming of data. Don't forget to feedback us and make queries related to Java development. If you have any queries regarding this topic or Java development, feel free to contact us or you can do comment. Our experts will contact you soon. Our email ID is info@aegissoftech.com. Our contact number is +919824172020. Our location is Royal Square, first floor, office number 110, near Shilp Tower, Tagore Road, Rajkot 360001, Gujarat, India. Thanks for watching at the end of the video. Please do like, share and subscribe to our channel for more knowledgeable videos.